Hello.
Yes, sir. Yes,
Yes,
sir.
yes, sir.
Okay, 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 okay.
Yeah. Just wait 2-3 minutes.
Connected है. CPU लाने की फिलहाल बनाना. So can we start the session?
Yes, sir.
छोटू ईयरफोन है क्या? देना देना, इससे कनेक्ट हो जाएगा. सर we start the session. एक कनेक्ट करने को एक बार.
Settings.
सेटिंग में ये चलिए लगा. इसको ऑन ऑफ करके देखते हैं ना. इससे कनेक्ट तो नहीं है ये.
नहीं.
Hello everyone, good morning. Am I audible?
Yeah.
Yeah. Paper ID 1077. Anyone present from paper ID 1077? The role of HR in sustainable and ethical supply chain management. Okay. Paper ID 1205. Arnindam. हो गया ना?
वॉल्यूम थोड़ा बनाना.
Can you hear me?
Arnindam.
Can you hear me, sir?
Yes, yes.
Yes, sir.
Yeah, I am giving you the rights to present. You can present your paper.
Sir, can you see my screen?
Yeah, please.
Yes, we can see your screen.
So
You
should I
may
start?
Yeah,
Okay.
you should.
So good morning, everyone. My name is Arindam Binlish, and today I'll be presenting my research on proposal and implementation of neural network-based approach for secure speaker recognition using spectrograms. So this is the abstract. So basically, in this era of artificial intelligence, we know that AI is becoming very huge, and speaker recognition is also gaining the forefront as we step into this AI world. And this paper, which is an efficient deep learning, in this paper, an efficient deep learning pipeline has been proposed, which is basically an online platform that automates the machine learning. A total of 7,500 audio samples were used from Kaggle speaker recognition dataset to create spectrograms, MEL spectrograms, and MFCC. So our goal was to see which out of these three have the most accuracy in predicting the speaker. And then a ResNet 18 has also been used. Along with this, regularization has also been used to avoid model from overfitting. And then three different types were compared to see which one gave the most testing accuracy, which was MFCC. And there was also advanced encryption standard AES used for secure speaker recognition task. So this is the introduction. Basically, we know that every human being has different fingerprints. Similarly, audio fingerprints are unique for each person. And deep learning is the method to process knowledge about the rules that govern the relationship between two or more variables using neural networks. This is the background study, the material that I've used for reference in my research study. Now that we come to the research method, so it starts from the input data, and there are multiple ways, as mentioned at the start, we use different steps and compared them. So the first process is we extract labels, and then we create the data set and use AES for security purposes. Then we split the data set into 60-30-10 ratio, and this is done by the automated machine learning. Then we train the modules on the speech features, regularize it, retrain it, and then we get the prediction accuracy. The other way is from the inputted data, we can extract the audio files and apply a Fourier transformer, which is basically used to convert time domain to frequency domain so we can get the features. From here, you can get the spectrograms by converting frequency to log scale, and then do the same method as mentioned before. You can get the MEL spectrogram by generating the MEL scale and map frequency, and finally, you can get the MFCC by using the log scale frequency and apply discrete cosine transform. And then it's the same process where you apply AES, split data, train, retrain, and prediction accuracy. So the dataset, as I mentioned, the start was a Kaggle speaker recognition dataset, contains 16-bit, 16 kilohertz audio wave files, and has speeches from five prominent leaders: Benjamin Netanyahu, Jens Stoltenberg, Julia Gillard, Margaret Thatcher, and Nelson Mandela. And each speaker has 1,500 samples, so in total 7,500. And all waveforms are in single channel pulse code modulation, which is basically used to convert analog into binary sequence. Now this is feature extraction. So a spectrogram, this is the spectrogram. So a spectrogram basically is a visual way of representing the signal strength or loudness of a signal over time at various frequencies present in a particular waveform, basically identifying spoken words phonetically and to analyze various calls of animals. And you can see that these are the different spectrograms created for all the five leaders. Next, we have the MEL spectrogram. So a MEL spectrogram, we have the MEL scale on the y-axis, performing nonlinear transformations. And MEL spectrogram basically breaks the audio so it can fix to low frequency audio and applies a filter to give resolution to lower frequency. Then you have the this is the MFCC. The MFCC are less sensitive to background noise and channel distortions, which makes them more robust for speech and audio processing tasks. Basically, they're less sensitive and they capture more of the perceptual information of the sound and are thus more useful for tasks that require human-like perception of sound. So, a total of 20 MFCC coefficients were extracted from the MFCC features in this research. Now, the ResNet model was also used. So, ResNet 18 is basically an 18-layer architecture which helps extracting audio features. It converts raw audio signals to meaningful characteristics so they can be processed. And this architecture is designed to allow networks to be deeper, thus improving their ability to learn complex patterns in data, and significantly enhances the training of deep neural networks by utilizing residual learning, and it also allows gradients to flow more effectively through the network. Now, this is the data split. As I mentioned, the start 30, 60, 30, and 10. So training data, basically the label data, 4,500 total, we have 7,500 data. So out of that, 4,500 was in training. Testing was validating the data to ensure and check everything is precise. So that's 30%. And validation is for the own model's efficiency so that adjustment can be made. And this was 10%. So the results that were evaluated by using the ResNet 18 models, the spectrogram had a 92.9% accuracy, which was achieved by using a variable learning rate between 1 e to the power 3 and 1 e to the power 5. And the model was trained for 200 epochs. Epochs is basically the instant of significant excitation of the vocal tract system during the production of speech, and they're usually taken because they can be changed. The MEL spectrogram based model generated an accuracy of 93.75, which was better than the spectrogram. And it was also used variable learning rate between 1 e to the 3 and 1 e to the 5, but it was trained for 325 epochs. The MFCC one had the most accuracy and is the proposed one, which is 95.2%. And the variable learning rate was the same, and it was trained for 325 epochs as well. And these are the references we used. So yeah, thank you.
Arindam, uh, Arindam,
Yes, sir.
yeah, yeah, I have some question for you. Can you show me your abstract?
Okay, 1 second. Can you see it?
Yeah. Okay, okay, fine. So, what the problem you identify in your research?
Basically, in our research, we are trying to find an efficient speaker recognition system, and we are suggesting using MSCC because it got the most accuracy in finding the speaker.
So, why you use the ResNet 18? Because we have another models also and neural networks. What the reason?
Uh, we basically use ResNet 18 because it converts raw audio signals to meaningful characteristics, and also because it allows gradients to flow more effectively through the network, which is crucial for training networks with many layers. And also, it improves the ability to learn complex patterns in data.
Okay. So, one more thing, how you secure your system because you use the advanced encryption standard algorithm. So, what's the reason to use this algorithm? Because we have another algorithm of cryptography. So, why you use this algorithm?
The coding aspect was handled mainly by someone else, but we used AES to ensure the security of the speaker, because right now we did the testing for 5 specific people. But going further, if you don't want any of the data to be leaked for the speaker, so that's why it had good security.
Okay, okay. Thank you. Thank you. Thank you so much. Very nice presentation.
Thank you.
Arindam, I have just one, I won't say suggestion. Are you giving the presentation for the first time?
Yes, I'm currently in grade 11th.
Okay. I think that
You are
there
11th?
was,
Yeah, I'm in 11th.
Really?
but how
Yeah.
come you are writing this?
Oh, very nice.
No,
So I
then though it is very good, but the only thing
Hmm.
is that there was a format which was being shared, and in that format you had to give the presentation. So you had just put the content in the presentation. Obviously, you are in grade 11. Then I don't have any complaint. I thought that you are a full-fledged researcher and you are doing the research. That way, though, it is very good. But otherwise, there was a format which was shared for giving the presentation. Otherwise, 11th
uh,
grade presentation from 11th grade, it was perfectly fine. No issues regarding that.
okay, thank you. I'll keep that in mind for next time.
Yeah. So please improve on your this thing. Whatever content you put, you had just put the content there. In presentation, you don't put the whole content. That's the only thing I just wanted to say.
Okay.
ठीक है. Okay. Thank you so much. Is 1077 paper ID? Anyone from 1077 present? Uh, okay, I don't think anyone is there from 1077. 1242, paper ID 1242.
Yes, please, I'm present.
Yeah, please, ma'am, carry on. Beta,
Please continue.
Yeah, I'm sharing the slides. That it's still loading.
Oh,
Yeah.
okay, okay. Fine, fine. Continue, please.
Hi everyone. My name is of Azid Ananyonga, and I'm doing my PhD at UNSW Sydney. Mainly, our research is about classification of operational records in aviation using deep learning models. And I'll be giving the details. And we are 2 people, me and my supervisor, Graham Ward. Mainly, I'll go straight to the content of this work. Mainly, we're trying to look at aviation industry and the dataset and the challenges that is there in the aviation industry. And then we are trying to see how we can overcome the challenges that is there using deep learning models, which has not been used widely. And then we are trying to see what we can do to make it improved in future. So aviation industry mainly is a very one of the safest means of transportation, but regardless of that fact, it still has some kind of challenges, and these challenges can we still need kind of can be reduced somehow to make sure that at least people they don't lose their lives, and then they don't lose properties and etc. So this data set in the aviation industry comes from very many areas. For example, they come from freight recording and very many areas. And then when this data is available, mostly it's being collected manually by the investigation authorities. So they correct it from different areas, like for example, asking the witnesses who were there, like for example, when an accident happened, and then all this data is being corrected and is being put into one place, like for example, ATSB Aviation Authority, Aviation Transport Safety Bureau network, and then there's also NTSB and many other areas that correct this kind of data set. So in this area, we've used the Socrata dataset. It is available, publicly available online, and it was published by NASA. So we've been using different kind of the dataset to see how we can figure out how the accident happens, why it happens, and how it can be solved using the deep learning models. This is rarely used.
Ajia, listen. Your, I cannot see your PPT. Your PPT.
Okay.
Yeah,
Clear now?
move forward. Move forward. Next. Yeah, it's done. Next. Next PPT.
You can see, right?
Yeah. Next, move. Okay, continue.
Okay. So like I was saying, so this is the problem that we're trying to solve. And here we are mainly, because this data set has got many records, so mainly we are focusing on operational records, whereby this records, it had very many kind of operational records. So we had to manually make sure that we categorize it into three category classifications, whereby we had to look at commercial airlines, we had to look at military, and then the private airlines. Anything that was not related to that was put aside. It was not related it was not put for this task, but it can be used in other tasks. So our main objective, we are trying to see how can these models improve the accuracy and the performance in classifying the records in those three classifications, and we're also trying to see if the aviation safety can be enhanced by improving the efficiency and the accuracy of these models. So mainly, we are working on NLP, natural language processing, whereby this data that is being corrected is a text narrative, and then we are trying to make sure that we based on the text narrative to make sure that we do these deep learning models. Traditional methods have been using different methods like SVM, ANN, but then this time around we are trying to make sure that at least we improve on the knowledge that is being worked on using the deep learning model. So we get the text data set, we clean it. After cleaning it, we remove the stop words, we remove the, like for example, the stop words, there is, and all those small words, because these words, they do not add a significant meaning in analyzing any model and each model's strength. So they're being removed, and after we transform the data into the numbers. These are the numbers that can be understood by the machine. So after it's being converted into the numbers, and then we do the model training. So this is the process that we go through. So after getting our data set, we apply these different models, and this is the model architecture. So we apply different models to make sure that at least we can get different performance and see how this can improve. So the results, basing on, since we've used different deep learning models, and among all these deep learning models, CNN excelled in classifying the commercial classification mainly with 81% precision and then 79% recall. But then generally, when all of it is combined, we realized that LSTM was the best classification model compared to all other models, like we can see here. Like we can say here that when it comes to the classification, we realized that commercial was performing better, but then this could have been due to the fact that commercial is being used widely and more than these others, and then it could have performed better due to imbalance, to data imbalance. And we tried to make sure that at least we can do different things to make sure that the data is balanced, but then we had to put it for future work to use different methods to make sure that at least we can improve, like for example, using the variation autoencoder, using the cosine similarity, and very many other methods. So basing on this, the classification, it clearly shows that commercial was having classified correctly better than these other models. And then like I've already explained that it could have been due to data imbalance, and this can be achieved. And how can this be achieved? So for this task, we are trying to see how these models can perform mainly on the operational records. So the same applies to this. Like we can see, like for example, here LSTM still achieved better than these other models, and it shows that these other models LSTM can widely be applied to mainly aviation dataset. And when we say mainly, it could be better in Socrata compared to other datasets. But then in other studies, including our own other studies, LSTM has always been performing better in all of the aviation dataset compared to any other model. So in simple terms, we can say that LSTM is good when it comes to aviation dataset, and it excelled. The fact that it excelled better in the commercial in the commercial class compared to all others, like military and the private classes. And then we also realized that CNN can perform better. But then still the future work, we realized that due to class imbalance, the model could have been performed better, maybe differently, if we had used different methods, different methods to balance the data set, like for example oversampling and then other methods. And then we realized that we can apply the ensemble learning to combine these models, and it could also help in the future work. And we also realized that not only on this work, but then on all work of the aviation industry, we've realized that when we can apply the explainable AI to make sure that the model can be able to give the explanation of why and how it reached to the level of getting the accuracy that it gives, it could be able to help improve in the aviation industry and help those who are the practitioners, help them to be able to make at least good decisions of basing on how and why the model performed before the way they perform, to make sure that at least it's not doubted. Thank you so much.
Okay, Abia. So, could you show me your data set part? Go back, go back.
Yeah, here.
Yeah, tell me. Okay, fine. Data set is yeah, this one. Okay.
So this was the
So,
only data set that was
okay,
available online on Socrata
so
mainly.
so which technique you use for data, like data compression, or to reduce the data size of the data? Which technique you use?
So this is the only records that are available for Socrata online. So we did to make sure that they have reduced was to do the data cleaning, because when you do the data cleaning, mainly it get reduced, because those with missing variables, everything that had any kind of missing values was removed. So that's how it reduced.
Okay.
But then
Okay. Which technique you use for the data cleaning? Which technique, which method, approach you followed for data cleaning?
this is exactly the approach that we used. So we use NLTK, and then we use the sparser in the Python. So how we do it to clean.
Okay, fine. Okay, you deep learning in 3 different models. So which model more suitable for you for your research work?
LSTM was the most suitable one. Yeah.
What's the reason?
Sorry.
LSTM is more suitable. So what's the reason?
Yeah, it was more suitable, but then it was more suitable. All of the models performed well, but LSTM was better. But then when it comes to commercial class, it showed that it was performing better. So this is where we are saying that the commercial class could have been better due to the fact that it had more instances than other classes. Yeah.
Okay, fine. Thank you.
Thank you. All right.
Ma'am, you have questions?
No, it's perfectly fine.
Okay.
Let's move to the next presenter, paper ID 952. Is
Ma'am,
anyone?
actually, I have one more meeting around 11:10. So
Okay.
please take care.
Okay, sir. 952. Anyone from paper ID 952? Huh?
Hello. Yes, ma'am.
Okay, okay. Rihana. Okay. Yeah, please share your presentation.
Yes, ma'am.
Ma'am, please limit your presentation to 10 minutes only. Is there any issue in joining?
No, ma'am. No, ma'am.
So why aren't you sharing your presentation?
Yes, ma'am. Hello. Hi. Good morning, ma'am.
Ma'am, share your presentation. We are not.
Yes, ma'am.
Your presentation is not visible.
My presentation is visible, ma'am.
No, it's not visible.
It's visible, ma'am.
Yeah, it's visible now. You continue
Yes.
and limit your presentation to 10 minutes only. After that, we
Okay,
will
ma'am.
stop you. Okay.
Okay, ma'am. Okay. I'm going to present about empowering social sciences with the data visualization. These are my table of contents. Introduction. Visual data. The visual data is used to communicate an easy and represent the data in an easy way. And aspects of many sciences, the powerful tool for description and exploration sciences in study. Data visualization has become the game changer for the social science based on the research by allowing analysis and under the complex data sets. Visualization is the easy to represent the visual or graphical data. So it uses the data visualization to represent and understood the easy way to represent the data. My problem statement is a temporal visualization has effectively understood the shifts in behaviors. Temporal visualization has a represent the data in a start and end time that has a start and end time, such as spikes in a Google Trends. In Google Trends, some search volumes became increased in increased search volume becomes increased in numbers. We use the spikes to represent the Google data trends during the major social events. Behavior patterns and other discuss the roles in the opposition given constraints. Methodology. This analysis defines a methodological approach based on the heterogeneous data that used in urban data dynamics. In urban dynamics, we divide the urban dynamics into cities, towns, and other suburban areas. The visualization methods used in this specification carried exhibit the intercity of the data. Then heat maps and many visualization techniques are used. Objectives. The study attempts to fill the gap by using open
obudde ndi mu conference
data visualization.
Continue.
Okay.
kati
So attempts
ndi
wanted to fill the
mukuwulira
gaps
waliwo
by using
research
the openly
omulala gwe
available
mbadde ndi
data set for the
interested
data
mu
visualization
kati
frame.
mbadde njagala
And put
mpulirize
heat map and both
Rest of the
and
participants, please mute yourself.
study integrates innovation, geospatial and temporal network visualization techniques that can enter scientists' ability to discover the hidden social issues to support the data-driven behavior admin studies policies. We use this data visualization techniques to easy predication and easy understanding and easy graphical level to understand the easy way to understand the graphical or visual representation of data. By results, the findings, the potential of new integrated data visualization method revealing dynamic human behavior figures. Some sites into urban growth areas were gained using the geospatial analysis. Geospatial analysis are divided into, depending upon the rural areas or urban areas or suburban areas. Using heat maps, we have divided into the maps and population density according to the areas divided into up to the past 10 years. We divided up to the area into cities, towns, and urban areas and suburban areas, depending upon the geospatial analysis. The temporal trends analysis reveals the pattern of the behavior. The seasonal consumer speaking trends around the seasonal and holidays were after the time series visualization of Google Trend data. The study results also shows the behavioral change in often prompted by exterior events, such as the economic downturn or the technological evolution. My results are combined analysis of the behavior with the urban data. This technique blends the behavior and urban data analysis, how both interact. At the end of the spectrum, low density rural areas highlighted insufficient digital use and illustrated enduring digital divide. These results stress on information inequalities must be cracked so people can access easy, digital sources easily. Heat map is designed to quantify the urban density across regions for simplification of the dividing. We use the urban density simplifications of the areas, highlighting highly dense areas such that the transport nodes. The result highlights the potential value of holistic method in studying complex social phenomena, present pathways for improved urban design and behavioral change decision making. These are my results and discussions. Depending upon the heat map, the urban growth area divided into these trends, the temporal dynamics, urban growth heat map, and behavioral trends. These are my results and discussions. Depending upon the urban density and people population and their growth intensity, we divided into the parts, we divided into the bubble chart, and we enhanced that computer network clustering heat maps. My conclusion and the future scope. We also summarize that the power these tools were used for social science and important visualization, behavior analysis, and urban dynamics. Urban dynamics is used to dividing the people upon their geospatial analysis into cities, towns, and suburban areas, or urban areas, or rural areas. Furthermore, these visualization tools have provided a solution to the gap between complex data and action by allowing researchers to tangible output for generating conclusions with their relative ways. The finding of this paper highlight the benefits of the multi-dimensional visualization in guiding a holistic understanding of a complex social phenomena. This framework can be improved by including predictive modeling to estimate behavioral trends and urban dynamics pattern, increasing the range of data sets applied to these models. Some ways, some ways to further improve accessibility and responsiveness: interactive visualization platform or real-time data statement, empowering policy makings and stakeholders like in observing the action data discussion, effectively addressing fast emerging social and urban changes. These are my references. Thank you so much.
Uh, what problem you identify in research? What is the problem you identify? Hello.
Hello, sir.
Uh, what problem you identify? What is your objective? CCT have to the
For for simplification of data, and we have represent the data in easy way. We use this data visualization and urban dynamics techniques.
okay. So you are say using deep learning. Some deep learning technique you used.
Yes, sir.
Which technique? Tell me. Tell me. Don't ask to your friends. Tell me which technique you used. Because you on simply you read your PPTs. Okay, you are
Deep
giving the
learning.
presentation.
Yes, sir. Data deep learning technique, we use CNN, RNN, and LSTM.
So what is the difference between CNN or RNN?
CNN means convolutional neural network, sir, used for
Uh,
image processing, sir.
but your not work is image processing. There is different work.
RNN,
What
we
is the
use
data
that
set you have used?
data sets.
Yeah. And what are the parameters of that data set you have used? You must have done, if you have done some research, you must be knowing that what all data set you have used and where from you have got that data set. And give me the name of one parameter of that data set. I'm not asking the all parameters what you have used. Have you done some research or it's just you have done the theoretical work?
No, sir, I have done a one part in this paper.
Okay.
So I don't know. She's done by some friends, so I don't know that about that.
Okay, no issues. Sir, if you have to ask any other question, otherwise we can go.
No,
to
ma'am.
next.
No. Next, please go next.
Thank you so much.
Paper ID 225. Anyone from paper ID 225? Paper ID 225, efficient hyperfuse model for stratification of current facial expression. Deepa ma'am, you are there, I suppose. You unmute yourself, you are not audible.
Am I audible now, ma'am?
Yeah.
Yes.
Yeah.
You can share your presentation and limit your presentation to 10 minutes.
Yes, ma'am. I understand. Thank you.
Okay. No, sure.
Hope my presentation is visible to you.
Yes, ma'am.
Yeah. Thank you. Yeah. So, good morning, all. And my paper is efficient hyperfused model for stratification of concurrent facial expression. So, we all know that facial expressions are very crucial in understanding other people in any environment. It shows a dynamic reaction of people, and therefore we tend to use some reason strategy hyperfusion model for classifying those facial expressions in real time. And these are the contents, and we use two primary things such as primary
Ma'am, your PPT is not moving. It's on the first page. You are going to the next page, so just move it.
Yeah, okay.
Go to the presentation mode.
Is that
F5,
moving now?
no, it's not. Slideshow mode, it's not working, it's not going. No, it's still there. Do it one by one, like go to the next page and then it's not in a presentation mode. Yeah, now. Ma'am, continue now. You are not audible, ma'am, at all. Unmute yourself. Ma'am, continue with your presentation. You are not audible. I don't know what is the problem. Is she audible to anyone else? Hello?
No, she's not.
Ma'am, unmute yourself. I think you're on a mute mode. Ma'am, you are not speaking. Ma'am, you are not audible. What is the issue?
Madam, not audible. You are not audible. Madam, you are not audible.
Deepa ma'am, rejoin the meeting, sir. First leave and then rejoin.
Ma'am, please say something.
Ma'am, remove your headphones. Maybe your headphones are not compatible. Speak with system voice. You are not audible, ma'am.
There is some issue. You rectify your issue. We will go with the next speaker. Then you can join after that.
Yeah, this is good, ma'am. Continue. Call next one.
1175 paper ID. One 1175 Bablu Kumar.
Yes, ma'am. Hello.
Yeah, Bablu Kumar, you have been given rights. Now you share your PPT.
Okay, ma'am.
You are on mute mode. You have to unmute yourself and share your PPT. रिकॉर्ड कर रही हूँ ना Bablu Kumar, what is the problem?
1 minute, ma'am. 1 minute.
So we don't have so much of time.
Hello, ma'am.
Yeah, your PPT is visible. Now continue and limit your presentation to 10 minutes.
Okay, ma'am.
Yeah.
Thank you, ma'am. Good morning, everyone. I am Bablu Kumar. I am from Patna. I have done my M.Tech degree from Central Rajasthan. My topic is Sign Language Recognition Deep Learning. This is my table of contents: introduction, literature review, problem statement, objectives, methodology, discussion, result, conclusion, reference. This is my introduction. Sign language recognition through advanced technology like machine learning and computer vision holds significance in several aspects of society, including education accessibility. Deaf and hard of hearing students face challenges assessing quality education. Bridging the communication gaps between deaf individual and sign language user is challenge. This is my literature review. Sign language recognition has recently gained much attention because it has the potential to bridge the communication between the deaf or hard of hearing population, the general population. Many techniques approaches have been explored, developed, and accurate, efficient sign language recognition system. The author proposed a novel CNN architecture for sign language recognition that utilizes residual learning multi-skill fusion. The model incorporates residual blocks to facilitate training and improve gradient flow. By fusing multi-scale features from different layers, the proposed approach achieved improved accuracy compared to traditional CNN architecture. Explored the fusion of static and dynamic features using CNN for sign language recognition. The employed a two-stream CNN architecture that synthesizes both spatial and temporal features just from sign language videos, and the fusion both streams significant. These previous works demonstrate the effectiveness of CNNs in sign language recognition by capturing and leveraging spatial information from sign language image or video. The integration of motion features, multi-scale features, residual learning, and spatial temporal modeling further enhance recognition accuracy. Additionally, studies addressing real-time performance and efficient model design to contribute to the practical usability CNN language. This is my problem statement. Sign language recognition involves the precise and efficient identification translation of sign language gesture into written or spoken language. Second, sign language recognition needs to consider variables like lighting circumstance, camera's perspectives, and obstructions, of all of which can impact the accuracy and resilience of the system. This is my objective. Image to character recognition, character to sentence translation, real-time performance. This is my methodology. Video and live video, frame extraction to filtering the keyframes, reprocessing, and go to deep SLR and go to pool of character, that's meaning. Methodology analysis. I have selected 3,000 images of different sign languages, providing a scaling pose and illumination purpose. There are 5 types in dataset. First, first type alphabetic consonant character sign. Second type delete signs. Third type space signs. Four types nothing. Five types character vowel character types. This is my result and discussions. The post-procedure model implemented using Keras and TensorFlow library in Python. OpenCV is used for image processing. Matplotlib is used for result analysis. In order to train the model, dataset divided into 2 types: training and validation. A total 75% of the data used for training and the remaining data we used for testing. This is my experimental result map. Number of epoch, training set, validation accuracy, validation loss. This is my graph map. The flowing graphs comparison, class-wise training set and validation set and validation accuracy, validation loss. This is my observation map. Number of epoch, training set, and accuracy and loss. The following graph shows the comparison of class training set and accuracy and loss. Experimental results: class 1, class 2, class 3, class 4, 5. Training image 935, testing accuracy 99, validation image 100, and validation accuracy 0.0156. This is a graph map. Conclusion: future scope. This work proposed a sign language recognition classification approach for the classification of sign language into 5 different categories. The approach is designed to work with aim to classify sign language in low-resolution images, scale, and pose invariant manner. Therefore, a deep learning model based on CNN and RNN is proposed. The deep learning model is trained on 3000 images. In the training phase, the model achieved a maximum accuracy 0.99% and the validation accuracy 0.94. Along with accuracy, various performance metrics were measured. Precision achieved 0.98 and recall achieved 0.98 and F1 score 0.97. The model achieved precision 0.98 and recall 0.98 and F1 score 0.99 during testing. Future scope: the integration of sign language recognition into diverse platforms offers the potential for instantaneous translation of sign language into a spoken or written language. This application holds the capability to facilitate effective communication between the sign language users and individuals who lack familiarity with sign language. Such integration can improve particularly beneficially in contexts like education, business meeting, healthcare, and public services. This is my reference, ma'am. Thank you.
Okay. Can you show me your first page?
Yes.
Go up, go up, go up. Wait. Go down, go down, go down. Next. Move next. Yeah, problem statement. So what the problem you identify? Tell me please.
Sign language problem होता है जैसे precise and efficient identification translation language to spoken and English language में.
Okay, so how to solve this problem?
I have solved 300 image and and my own image and classify image processing CNN model लगा के.
CNN model लगा के.
Yes.
ठीक, okay, fine.
I have one question as a layperson. How is it going to be as a layperson? Matlab like I'm not a technology person, but as a layperson, how is it going to benefit me? Like sign language, you are saying that you have done a sign language recognition, huh?
Yes,
So
ma'am.
will it convert it into some language, sign language into some other language which I can understand, or how is it going to work? You have mentioned sign language recognition, huh?
Yes, ma'am.
So
Yes, ma'am.
sign language recognition means obviously I don't understand the sign language, but as a layman, how will it be beneficial to me? Will it convert the sign language to any other language which I can understand, or is there any other method I'm not able to understand? Can you make me understand that?
I have no idea, ma'am.
So why are you then recognizing the sign language? What is the use case of this?
Beneficially,
What is the use case of this problem statement if you don't know okay, where it will be used and how it will be used, you don't know. So what is the fun of doing any research?
whatever beneficial for deaf and hearing people, ma'am.
Deaf and hearing, but how will they recognize? Are they supposed to know some of the any type of thing they are supposed to know to understand this language? Matlab like I don't know, because the deaf and dumb person, they already understand those sign languages. How your research is going to help them?
अभी नहीं है इनके पास आंसर में उनका.
चलिए कोई
Sorry,
बात
ma'am.
नहीं, leave it.
Thank you.
We are having
Thank you.
Deepa.
Deepa.
Ma'am, please unmute yourself, please first. Let's see whether your sound is working or not.
Ma'am, am I audible, ma'am? I have
Yeah,
unmuted.
please.
Yes.
Yeah.
Yeah.
Continue. Share your screen and continue.
Yes, ma'am. Ma'am, can you see the second, I mean, other
Yeah, ma'am,
window?
continue.
Yes.
Yeah.
Yeah. Okay. Yes. Yes. So mine is facial expression recognition. I use these algorithms, that is principal component analysis and support vector machines. We already know about these algorithms that are very traditional. The idea is to combine both algorithms. First, to use the principal component analysis, which uses unsupervised method for dimensionality reduction, and we make the components into very smaller and granularity, and then we feed this input to support vector machines SVM. This uses supervised learning. So instead of going for separate algorithms either for or PCA or SVM, we try to combine both the algorithms and try to get the best features out of both. So we go for unsupervised in the first part and feed the output to the SVM in the second part. So hyperfusion is but the combination of PCA and SVM, as we have seen in the previous slide. When we use PCA, we reduce the dimensions. We take only the principal dimensions so that we reduce the data. And SVM's biggest benefit is to concentrate on the key patterns. It is more accurate than any other algorithm, and it prevents the data overfitting to the main thing. And even the unseen data, which has not been seen during the training phase, that can be dealt very well with this SVM. So when we use as a hyperfusion, which is proposed, it is very valuable in terms
Ma'am,
of.
excuse me, ma'am, you're on second slide only. If you
Okay.
think you have moved to any other slide, you are on second slide.
Oh, okay, ma'am. Yes, I've just moved to other slide. Is that moving now, ma'am? Is that moving now?
Yes, yes.
Okay. Yes. So yes. So here we use the combination of PCM and SVM, as we told earlier. SVM, yeah, sorry. PCA reduces the dimensionality of the data, which is we can just choose the higher dimension is required and leaving all the lower level details. Whereas SVM helps us to identify the key patterns, leaving the lower details as well as, and improves accuracy. And we tend to handle the overfitting of data. And when we use this proposed hyperfusion model, we process even the real time thing, even when the list of resources are limited. That is the main idea. And the objective is to achieve the superior performance. That is when we use the CK plus data set, we yield up to 90.3% of accuracy. That is really comparatively better when we use any other model, any other algorithm. And
Deepa
when
ma'am,
we
your
go,
presentation is minimized to 10%. Kindly increase the size.
okay. Is that okay, sir? I'm in methodology and analysis slide. I hope you can see this slide and the 100%. I have zoomed it.
It's showing the
Okay.
problem statement at the top.
Problem.
Hyperfusion combination of PCA and plus.
Oh,
Ma'am, you have a time limit of 10 minutes and we are just stuck on presentation only.
okay, ma'am. Okay, 1 minute, ma'am. Sorry, I don't know what's wrong here. Let me just explain orally. It's like I think it got disconnected. Hello. Could you see my screen?
Yes, ma'am, we can see your screen, but it is not moving. You continue with whatever you have to.
Yes, ma'am. Yes, ma'am. Sure. Yes. So the pixel instant, the methodology involves in the pixel intensity calculation, where we take the summation of all the white area and we reduce the black area, and later we apply the convolution of image filters, and then we decompose the eigenvalues, and finally apply the SVM. This is what the methodology and analysis is. And then yeah. So if we give the input phase as well as the new phase, we compare both the things. We pre-process the image and features are extracted. Then in the PCA process, we compute the covariant matrices first. Then we compute the eigenvalues and eigenvectors matrix. And we select the top k eigenvectors from these values. Finally, we reduce the dimensions in PCA. This is part one of the process. Whereas in SVM training, we define the hyperplane, and then we maximize the margin limit, and then we finally classify. These three things constitute the SVM process. So the first part, PCA's output, is given uh, to the SVM as input, and SVM takes that input and processes that and produces the final facial expression. And we try to categorize the real-time facial expression into different categories, like it may be happy, sad, or neutral, disgust, contempt, whatever we are. We just try to analyze the real-time facial expression by these means. And in the future work is, instead of just facial expression alone, I try to go for the multimodal integration, that is voice, body language, and other things. All the parameters are included, so that we would look for a algorithm that can predict the expression of the person well in the real time. This is what my proposal is. Thank you, ma'am. With this, I finish my presentation. Thank you, sir.
I just wanted to know, okay, that what features have you captured as far as the facial expression is concerned? If you are trying to have a sad face, how can you make out that this face is a sad face? So, what features have you extracted
Yeah.
to find out
Yeah.
that the
Yes, ma'am.
yeah, continue.
We have lot of muscles, like we go with a muscle kind of perspective. In facial, near the eyebrows, we have something called as orbituralis oculi, that muscle, and near that mouth, we have orbitocloris or ori. So those muscles, I take the corners of the eyes, as well as the portion of the eye, as well as the lip expression, and we try to compute that thing, and we make them into a numerical value. If it is greater than the threshold, we consider that for happiness. So for every expression, we have a predefined set of expression of a muscle. So if the muscle moves in that
Can you tell
particular
me
way.
any feature, like parameter of your data set?
Yes, ma'am.
What?
Yeah, there is something called as Dutchney smile, and that is called as a marker, Dutchney marker we have. If that is the Dutchney marker, if we have something called as a Dutchney marker, for example, if I smile, my lips are very wide, and my eyes also, no, instead of like, it will pull back and it will show a kind of natural expansion. So if there is something called as a Dutchney marker being seen in the image, I can say that it is a genuine smile and accounted for happiness. We have all the facial markers, which is called as facial action units, FAU, and we use such concepts, which is already proven by Paul Ekman. We incorporate all those features into this, ma'am.
Have you tested it on real data set?
Yeah, ma'am. We have tested to some
How
basic
much?
extent, but
How much accuracy have you got?
we got for we are able to produce
Real
very good
data.
accuracy
Real.
for happy and sadness, ma'am. But for neutral, we are not able to identify that thing. So we are working on certain things like neutral and disgust, ma'am, because the accuracy is little lower. So we are training in a better way for the real-time data.
Okay, thank you so much. Any other question from anyone else?
Thank you so
Thank
much
you,
for
ma'am.
your patience. Thank you so much for your patience, and I'm really sorry for taking long
No,
time.
Okay, okay, fine, fine, fine.
Yeah, thank you, sir. Thank you, ma'am.
Any other? Any other? Paper ID 1077.
So 7024 is present. So if you allow, I can present my paper.
No, your ID
724.
172. No, no, we do not have your paper ID, sir.
Sir, ma'am has shared a link with me. The Pinky ma'am.
Archana ma'am.
sorry.
Archana.
Yeah. Dr. Ajit
Dr.
Singh. Acha, Pinky ma'am has shared a
Ma'am,
link with you.
yes, ma'am. In the morning itself, I made a request for an online presentation. So,
Okay.
ma'am
So
shared a
yeah,
link with me.
you can no issues. Just tell us the paper ID.
Ma'am, it's 724.
724.
Energy efficient location based XML indexing.
Just what is the who are the presenters? Your authors?
Vikas Goel, Amit Goel, Ashutosh Sharma, Vikas Jain, and Mayank Singh.
I will write only one name, the one who is presenting, huh?
Vikas Goel.
Vikas Goel. And what is
Doc,
the paper? This thing. Title of the
energy
paper.
efficient, energy efficient, location based XML indexing in real time wireless data broadcasting for IoT devices.
Yeah, you can present. इनका वो कर दो. Give them the right. Sir, please limit your presentation to 10 minutes.
Yeah, sure, ma'am.
Continue, sir. Continue.
So my slides are visible?
Visible. Continue.
Yeah, thank you, sir. Good morning, one and only present for the presentation. Myself, Dr. Vikas Goel, and I'm going to present my paper, Energy Efficient Location-Based XML Indexing in Real-Time Wireless Data Broadcasting for IoT. And my paper ID is 724. Here is my content for today's presentation. I start from the abstract, then introduction, then related work, then proposed framework, implementation, experimental results, conclusion, and last references. So abstract, first of all, the Internet of Things, or we can say the IoT, is fast revolutionizing a number of sectors by performing real-time data collection and analysis. Especially designed for IoT applications, this particular paper proposes a comprehensive framework for location-based XML indexing in real-time wireless data broadcasting. To enable the effective geographic-based XML data searching, we propose a spatial XML indexing technique. The suggested solution also ensures the energy efficiency of the various IoT devices which are connected while addressing the issue of scalability and changing the data environment. So start from the introduction. So as we all know, the IoT devices makes it possible for sensors to connect the online, like the wearable smartphones and the smart vehicles, or the we can say the other smart gadgets. So in every facet of life, including the smart agriculture, smart education, smart health benefits, uh, there are a lot of area in which we can see the IoT as it is depicted in the figure also. The main thing is the quantity of the IoT devices are also growing over a time. So with the the growing demands of the smart automated system across multiple industries and the increased connectedness of gadgets have propelled the rapid rise of the IoT network also. And the amount of data created has increased dramatically as more gadgets are connected to the internet. Large and varied data sets are produced by the constant data transmission from every IoT devices. And by the end of this year, 2025, there will be a more than 75 billion connected devices globally producing zettabytes of data per year, according to the projections. In terms of data management, storage, and processing, this data burst poses a major issue. So, cloud computing and other traditional methods are which process the data are finding it difficult to keep up with the sheer amount, speed, and diversity of IoT data. Especially effective low latency data disruption is necessary for the real-time applications such as the location-based services, or we can say the LBS. So in order to handle the volume and the complexity of the IoT data, sophisticated technologies like XML indexing, edge computing, machine learning, and the real-time wireless broadcasting are merging together to provide a perfect solution. So the solution, or we can say that the location-based services (LBS) is depicted in a figure, which we can say that has more popular, opening up applications in supply chain management, in smart cities, and the environment monitoring system. Contribution. So this study aims to address the major issues of effectively indexing and transmitting the data on the location. So in this particular paper, we are proposing a special indexing mechanism for XML data, an effective broadcast protocol tailored for the IoT devices, and evaluation of the proposed framework. So here are some related work which has been done in this particular area, but one or to the another research paper has some problem or some has issues. So we have clubbed the issues and we try to come up with a new framework or the new proposed work to facilitate the effective real-time distribution of location-based Internet of Things data. And we are going to propose a broadcast protocol also. Data modeling and the spatial indexing are also integrated into the proposed framework. The proposed system organizes indexing and broadcast data in a scalable way to meet the difficulties presented by extensive IoT deployment in the dynamic situations. So start from the proposed work. The first thing is the data model. So the foundation of the data model is the XML, which is used to organize and make machine readable the data gathered from the various IoT devices. So here is an example of the IoT devices in which the device is there and we have the ID, then the location, and the device is identified by the latitude and the longitude, and it is transferring the two parameters, the temperature and the humidity. So to characterize the status of the each IoT devices, the model gather necessary information such as the sensor reading, which currently is the latitude and the longitude, and the parameters, that is the temperature and the humidity. The second part is how we are going to organize the data. That is the spatial indexing. So this framework indexing the geographic coordinators of IoT devices using an R tree. So a well-known hierarchical data structure. So this enables quick querying of geographical data such as the position of the particular device or a group of devices in a certain area within the minimum bounding rectangles, which is also called as the MBR. Adjacent objects, in this case, devices are grouped to form a R tree. So in this figure, you can see the example of the R tree. So at the top level MBR, then the MBR of two devices are connected together, that is a 123 and 124, and in the rightmost we are connected two devices 125 and 126, and those devices are geographically connected through these MBRs. So steps to generate the RTR is just the two steps. The insert the device location as a point in 2D space and form a bounding boxes. The third is the broadcasting protocol. So by using a multicast technique, the proposed broadcasting protocol enables the system to deliver the data to several IoT devices at once. So in contrast, unicast approaches result in is inefficiency since data is delivered in each device separately. So surrounding devices, sensors, reading are also combined via data aggregation techniques. Implementation, though, we have a system architecture, an indexing engine, a broadcasting server, and a data collection module make up the system architecture. Information from the various IoT devices is gathered and formatted as XML by the data collection modules. And last, the data dissemination is managed by the broadcasting server, and the indexing engine is responsible for query request and the R-tree maintenance. Performance matrices. So three parameters we are going to estimate, through which we are saying that the this particular proposed framework
Sir,
is good
your
or bad.
time is
Ma'am,
you have to wind up this now.
okay, ma'am. So the first parameter is the query response time. It gauges how fast the framework can respond to the query. Data throughput, it speaks about the volume of the data, and the energy consumption, the energy which is required to process a particular query. So these are the result which I have gathered by varying the number of IoT devices, start from the 500 to the 5000. The first is the point query response time, and the another is the range query response time. The another is the data throughput. Again, we are varying the input, the IoT devices from the 500 to 5000, and we are gathering the data throughput that is 200 to 750. The energy consumption is again by varying the devices, we are calculating the energy consumption. So analysis, the query response, our proposed framework provides fast, we can say the query response time. The data throughput efficiency, or we can say the efficient use of bandwidth is demonstrated. And energy consumption, the low energy consumption per device is indicating that the framework is energy efficient. Conclusion, a comprehensive system for location-based XML indexing in real-time wireless data broadcasting for Internet of Things devices is present in this particular paper. Utilizing effective broadcasting protocols and geographical indexing techniques, the framework improves the scalability and the performance of the IoT data dissemination. The suggested solution also ensures the energy efficiency of the various IoT devices while addressing the issues of scalability and changing data environment. The finding shows that the suggested framework successfully handles the difficulty associated with managing the location-based data in Internet of Things. These are some of the references which I have used. Thank you. Thank you for listening me. I welcome any query.
Just one question. Is it have you implemented it in a simulation based? You said that
Ma'am,
you include the IoT devices
not right now. Not right now.
It's just a
Mathematical,
theoretical what you have done.
it's a theoretical. It's a basically it's a new idea, so it's a first phase. Because in this paper you might have find that I haven't compared with the existing techniques. The actual implementation, implementation will depend on after that we can the compare the things also. So actual implementation is still we can say the in pipeline, ma'am.
Okay, no issue, sir. Continue.
No issues. Thank you so much.
Okay,
So
thank you,
I
thank you.
think
Thank you, sir.
we have
Thank you.
completed our all these participants. So thank you presenters for presenting your work, and thank you Dr. Ajit Singh sir for your valuable insights. I
Okay,
think
ma'am. Thank you so much.
presenters will take your whatever guidance you have given them. They can implement that in their work
Ma'am,
and
there are some
hopefully
like
improve. Yeah, बताइए.
uh, there is no Arvindam work because I am very surprised why he say I am a 11th standard
Yeah,
students.
he, like, the
Really.
way he presented and everything, it was really very good. I think other presenters should basically look up to
See,
him that how that
yeah,
work is being presented. The only thing was
yes.
that PPT was not in the formal manner.
Ha,
Otherwise, the
ha.
way he presented and everything, the way he explained, it was really commendable.
Yeah. Okay, ma'am.
ठीक है.
Thank you so
चलो,
much.
thank you so much. Thank you. All of you can leave now.
Okay, bye.
इसी लिंक पर नेक्स्ट